C. C was built in the early 1970s at Bell Labs, mainly to make building operating systems and system tools realistic without writing everything in raw machine instructions. It's small, fast, and close to the hardware, which sounds impressive, until you realize that also means it's easy to break things in spectacular ways. In C, you're trusted with memory. That's like being handed the keys to a sports car and being told, sure, you can drive it. Also, the brakes are your responsibility. This level of control is exactly why C became foundational. You'll find it under the hood of operating systems, device drivers, embedded systems, and performance-critical libraries. It's not the language that makes trendy apps, but it's the reason your computer can even run the trendy apps in the first place. And here's the part most explanations skip. Almost every modern programming language exists because of C, either copying it, fixing it, or desperately trying to escape it. Which brings us to the language that said, what if we keep the power and add chaos? C++ started as C with classes, and its whole idea was adding higher-level structure to C without giving up speed. It became its own language in the 1980s, and is still one of the most important choices when performance and control matter. C++ powers massive software systems, game engines, high-performance desktop applications, parts of web browsers, trading platforms, and systems where a little slow turns into we just lost a lot of money. It gives developers object-oriented tools, templates, and a huge ecosystem. It also gives enough complexity to keep people debating design choices at 3 in the morning. It's not hard in one specific way. It's hard in the there are 12 correct ways and all of them start arguments way. But raw power isn't what runs most of the world. Most of the planet runs on something far less exciting and far more reliable. Java. Java launched in the mid-1990s with a promise that sounded almost magical at the time. Write once, run anywhere. The trick is that Java usually runs on a virtual machine, allowing the same program to work across different operating systems without being rewritten for each one. That reliability made Java a favorite for large organizations. It's common in enterprise software, banking systems, massive back-end services, and a big part of Android's history. Java tends to be wordy, but that structure is exactly why huge teams can maintain massive code bases without everything collapsing into chaos. Java is the programming equivalent of a sturdy office chair. Not exciting, but it won't randomly collapse during a meeting. Now here's where everything changes. Because not every problem needs enterprise software. Sometimes you just want results. Fast. Python. Python was first released in 1991 and was designed to be readable and approachable. That's why it became the first language for so many people, and also why it's still used by professionals who could choose anything else but prefer finishing the project before the sun burns out. Python is flexible. It's used for automation, web backends, data science, and machine learning. Its real strength is the ecosystem, libraries and tools that let you build useful things quickly. Python usually isn't the fastest option, but it's often the fastest way to get from an idea to a working result. And for most people, that's what actually matters. But none of that matters if your code never reaches the user. And almost every user on Earth meets software in the same place. JavaScript. JavaScript is the reason websites aren't just digital posters. It was created to make the web interactive, and now it's everywhere. Almost every website you've ever used relies on JavaScript in some form. Because it runs directly in the browser, JavaScript controls animations, buttons, menus, video players, and everything that reacts when you click or scroll. Over time, it also became a serious server language, so JavaScript now lives on both the front end and the back end. It's powerful, flexible, and sometimes confusing in a way that feels strangely personal. At some point, JavaScript got so powerful that developers realized something terrifying. This thing is running everything, and it's barely supervised. TypeScript. TypeScript was introduced by Microsoft in 2012 as a typed version of JavaScript. You write TypeScript, and it gets converted into regular JavaScript that can run anywhere JavaScript runs. This matters because modern web apps aren't small anymore. As projects grow, JavaScript's flexibility can turn into bugs that appear at the worst possible moment. TypeScript adds optional static typing, which helps catch mistakes earlier and makes large code bases easier to maintain. It doesn't replace JavaScript, it just politely stops it from smiling, nodding, and then breaking your app in production. So now you have applications. But applications are useless without memory. And that's where one quiet language controls almost everything: SQL. SQL is the standard language for working with relational databases, which are organized systems that store and retrieve data in tables. If an app remembers user accounts, orders, payments, messages, or anything important at all, SQL is probably involved somewhere. SQL looks almost like plain English on purpose. You ask for data, filter it, combine it, sort it, and summarize it. It's not about building full applications. It's about controlling the data those applications live on. Once you understand SQL, a lot of software suddenly makes much more sense behind the scenes. And finally, there's the language built specifically for the modern internet. Fast, clean, and designed for systems that never sleep. Go. Go was designed at Google in the late 2000s with simplicity and speed in mind. It was built for modern servers that handle huge numbers of requests at once. Go is popular for cloud services, networking tools, and back-end systems that need to be reliable and efficient. It's opinionated in a very specific way. There's usually one clear way to do things, and the language encourages consistency over cleverness. It doesn't try to impress. It tries to work. So yeah, C and C++ sit close to the metal. Java runs the corporate world. Python runs the get-it-done world. JavaScript runs the web. TypeScript keeps JavaScript from freelancing too hard. SQL runs the data. And Go runs a huge chunk of modern internet infrastructure. But here's the thing most beginners don't realize. Your code is only as fast as the machine running it.